Hello and welcome to section 2.8. This video introduces a special property of continuous functions known as the intermediate value theorem. Take, for example, a person's height, related as a function of time. Barring a tragedy, as a person ages, we would describe their height as continuous. That is, there is a constant flow. If I was 3 feet tall at age 3 and 6 feet tall at age 28, then you would expect that there is an age between 3 and 28 where I was 4 feet tall. In fact, you'd expect there would be an age between 3 and 28 for every height between 3 and 6 feet. Attaining these intermediate values is exactly what the intermediate value theorem guarantees. Given the continuous function f on the interval a, b, since continuity has a constant flow, if we take any y value n between f of a and f of b, we can expect to find an x value c between a and b, where f of c is equal to n. That is, because a function is continuous, you would expect all intermediate values to be attained. With continuous flow, no intermediate value is jumped. This is a fundamental property of continuity. By dropping continuity, many examples would contradict the conclusion of the intermediate value theorem. Take, for example, hair length. Most people get haircuts, which would add a jump discontinuity to the relationship between hair length and time. Say at time A, my hair is 9 inches long, and at time B, I get a haircut, and my hair is now 3 inches long. Because my haircut introduces a jump discontinuity, there is no guarantee that my hair was over 5 inches long between time A and B. The barber could have cut from 9 inches to 5, then down to 3, but the point is, without continuity, there is no guarantee of intermediate values. The intermediate value theorem could be used in many ways. The most accessible example would be to locate intervals, for which we are sure a root of a function exists. How would we go about finding roots, otherwise known as zeros, of any polynomial? We know that polynomials are continuous for all values, so with the intermediate value theorem, we can try and find x values who have y values which switch from positive to negative. Take, for example, the x values -1, 0, 1, and 2. We look to these y values to see if there is a change from positive to negative. We look to their y values to see if there is a change from positive to negative. Between x equals 1 and x equals 2, the y value switches from -1 to 12. On this interval, the intermediate value theorem guarantees us a root, since 0 lies between -1 and 12, and f is continuous. Therefore, there exists a value c in between 1 and 2, where f of c is equal to 0. You've seen the basics, now gain mastery through practice and study.